Hi, in this video we're looking at domain and range. Remember that domain is all the possible x values of a function. Your range is all the possible y values of a function. Domain represents your input values. Range represents your output values. In this case, we are looking at an example where we have just two values for x, 1 and minus 2. So we would list them as x is an element, minus 2 and 1. If we look at our y values, which is our range, we have 3 and minus 3. So we can list that as y is an element of minus 3 and 3. Graphs are more challenging. The arrow indicates that the graph goes on in both directions to negative and positive infinity. So we use a vertical ruler method. If we place our ruler at any point on the x-axis vertically, will we get a point on the graph? And I want you to watch as we slide the ruler. Anywhere on the x-axis, if you place your ruler vertically, you will get a point on the graph, which means there's no restriction on the domain. So we will conclude that x is an element of reals. In a similar way, we look at the range. Using a horizontal ruler, we slide up, and you'll notice that there's no restriction. For every value on the y-axis, you will get a point on the graph. If we look at where the line is right now, where y is equal to 10, you will get a point on the graph. So y is an element of reals. We can use another notation to represent x an element of reals, as x is an element from minus infinity to infinity. In the same way, we can do that for y. Y is an element minus infinity to infinity. Remember, a round bracket means it does not include. We go to a straight line that is not going on to infinity. It has a starting point, minus 2 minus 1, ends at 1, 2. Remember, x and y. So we're going to use the same method, a vertical ruler method. But our ruler now will have to start at minus 2 on the x-axis. And we slide. And the ruler has to stop at this point on the x-axis, which is 1. So we can conclude that our domain is an x element starting at minus 2 on the x-axis and ending at 1 on the x-axis. Includes minus 2, so we use a square bracket. Does not include 1, round bracket. Looking at the range, we start at minus 1, we slide and go to 2, which tells us that the y is the element of minus 1 on the y-axis to 2 on the y-axis, includes minus 1 because we have a colored circle, does not include 2 because we have an open circle. We can rewrite this with saying x is less than 1 and it's greater and equal to minus 2. With the y, we can do the same. Y is less than 2 or y is greater and equal to minus 1. But also remember, we have two notations here. One is called the interval and the set builder. So there's our interval notation, set builder notation. You can choose one. We look at the parabola, and we're going to use our same popular method, vertical ruler method. So we're starting to slide for the domain. You'll notice that if we place our ruler, and remember the graph goes on to infinity, so wherever you place your ruler vertically, you will get a point on the graph. If I place the ruler here, I'll get a point on the graph around there. So the domain, there is no restriction, so we say x is an element of reals. But if you look at the range, the lowest value on your y-axis is negative 2. So your ruler starts to slide from there, and it goes on right till infinity, which means that your y is greater and equal to minus 2, which is the turning point. We can rewrite in set builder notation or interval notation. Let's look at this parabola. If we're looking at this parabola, we're starting at 1 on the y-axis, which means that it will not go above y on the y-axis. So from the last method, remember, your domain, there's no restriction. X is an element of reals. But if we look at our range, we're starting at 1 and going to negative infinity, which means that y is less than and equal to 1. We come to the hyperbola. And the hyperbola has asymptotes. Remember, the x-axis and the y-axis are asymptotes. The x-axis, the equation for the x-axis is y is equal to 0. Equation for the y-axis is x equal to 0. So we want to find the domain of the hyperbola. And you'll notice as we slide, when the graph is on the y-axis, it does not touch the graph. And that makes sense. So we can say x is an element of reals. So we'll be able to get x. So looking at the domain, we can conclude that x is an element of reals, except x is not equal to the asymptote, which is 0. And in a similar way, for the range, if we do our slide, you'll get a point except at the x-axis. So we can conclude that y is an element of reals, except y not equal to the asymptote, which is 0. We're going to the exponential graph. Similar to the hyperbola, we're going to slide the ruler, and there's no restriction on the x-axis. We'll get a point on the graph anywhere on the x-axis. So we conclude, if we go to the range, you'll notice that the lowest value that the graph can actually reach is 2. But it does not include 2 because 2 is your asymptote. Similar to the hyperbola, we will say that y is greater than 2. But in this case, not including 2 because 2 is an asymptote. Thank you.